my goodness, Baji. So Baji Baba let me know this week that he is quite quantum entangled with Sachi Mama. Now Suji here, who I also call Sachi Mama, she has many interests and she really thrives with a lot of activity, exercises, hunting, jumping, She has zoomies, and sometimes Baji feels a bit I felt. Sometimes Baji feels a bit left behind from these activities, and he would like to remind everybody but that even though that is the case, he is quite quantum entangled. And with just like those two electrons or two particles with the opposite spins in spooky action at a distance that we talked about a while ago, even if there's infinite distance between those two particles, if one of them is spin up and you find the other one infinitely far away, its spin will be down and it will be complementary to the other one. And that is what Baji believes he is with Suji Mama. And in fact, he proved this with his adoption. When he was adopted, actually, I was there to adopt Suji. And hi, my grass is greenest. Hi, Baji. Do you think that we are a way for the universe to know itself? Oh my gosh, that's a great question. That gives us a lot of a big amount of things to think about. Hi, Baji. Do you think we are a way for the universe to know itself? Hi, Pranay. How are you doing? So, when he was adopted, he was actually in the cat carrier with Suji, and she was actually getting adopted, and he jumped into the bag. Baji's wave function was observed in the cat carrier bag, and well, he's interested in Suji more than the camera, yes. His wave function was actually found in the cat carrier. Surprisingly, we didn't know that he would be observed there, but he was, and that is how we know because he's observed, that is how we know that this happened. I don't before the observation, I don't know which state he was in, but he quantum entangled himself with Suji and was observed in the same bag, and then they were adopted together. So, and ever since they have been together, so they do all their things together, vet appointments and travel and everything, living together. They cannot be separated because these are two quantum entangled kitty cats. Right here is Baji. Hi, Baji baby. Hi, Baji baby. Oh, Baji baby has been so sad because sometimes Suji Mama goes and does her own things, but physics says that they're still quantum entangled and that bond cannot be broken. But sometimes she doesn't want to share her space with Baji. Baji, OM3, why don't you visit India? Hi Ben, shalom. Look what I got, by the way, guys. I have a new book for you. We're going to be studying from this. It got a little bit wet because I went swimming and the book was in my backpack. So let me just turn the pages here for you before I face the camera. Hi Ben, how are you doing? Long time no see. I've been a little bit not able to do my lives as much lately, but here I am. So I hope to see many of you here joining tonight. And Baji is also joining the class, and he is also here to teach you as a, as a live example of quantum entanglement, which he is with Suji. So, Astrophysics for Dummies. I mean, I don't call anybody a dummy, but that's what the title of this book is. It is by Cynthia Phillips, PhD, who I believe works at the Jet Propulsion Lab, or at least she did. Just double check that one. It might be in the back that it says that. So let's read that real quick. Cynthia Phillips, PhD, is a scientist at the NASA. I was about to say national, but NASA Jet Propulsion Laboratory. Previously, she worked at the SETI Institute for 15 years. Shayna Pryor is a technical writer who has co-authored many projects with Cynthia Phillips, including the Frameworks series on architecture. So, what I like about this book is that there is a lot of information here. It is a lot of astrophysics in the same one book. So, it will come in handy for us and review many of the topics that we like to discuss here on the channel. So, we will do that. I know I've been so busy with my various projects, I got a bit overwhelmed. I'm just turning the pages for you to see this book really quickly. And then, actually, let me place the phone over here so that we can talk a little bit better. Can I just put that there? I'm making a makeshift phone stand for myself. There's the microwave that I use all the time and the stove that I never use. So here I am, by the way. Oh, you're falling. The phone is falling. 1 second, everybody. I'll be right with you. So, okay. Give me a moment. In fact, you stay on the book. Maybe that's how you can learn quicker. Maybe I just give you the book. So, how is the audio, guys? I know that there have been some issues with my audio sometimes, and I do hope that that is not the case today. So, how is it doing in that regard? I need to find something a little bit more solid here. So at first I thought I will go on with quantum mechanics, and Baji really likes quantum mechanics, given he's a cat who is quantum entangled with another cat. But I'm also excited about this book that I got from the library today for you guys, and it does promise to be a very good, easy to communicate way of talking about astrophysics, and so I am infused by that. And again, I hope many of you will be joining me tonight. I know there has been a long gap in our lives, and I am very sad about that. Indeed. Okay, here I am. Hello, guys. How are you doing? I know it's been a long time. Hello, Felipe. Oh my gosh, I remember you guys. I do remember you guys. Is the Quebec, or what? IO is CO Beck? What does that mean? Okay, so great. We have 5 likes. We would really love to get more likes than that, but thank you so much, everybody, for being here. Hello, Ben. How are you doing? Felipe is saying good. Hello, MGA84. What book is that? This is called Astrophysics for Dummies. Not that I am calling you a dummy. I have my moderator here, so just be a little careful with your weird comments and try to be non-weird. When are you coming to Lombard? Adeni chai prices are rising. Okay. I don't know what the Adeni means, but not you. I hid the comment. I'm from Brazil. Oh, hello, welcome to Brazil. So, let me set up the live. Please do subscribe. Thank you so much, guys. You were supposed to come to Chicago. I will in the summer. Lombard. I don't know what that is. Is that a place close to Chicago? I'm not very familiar. So, you'll have to tell me. Nice chai at Gava House. Desi spot. Okay, perfect. I will have to keep that in mind. Girl, so much to tell you. Thank you. So keep on sharing in the comments, guys. I need to go to the live monitor and do a couple things. And if you have any questions, I'm gonna go good night. Okay, good night. If you have any questions, do let me know. I will try to address them. Ben, how are you doing? Are you all good? And how is the audio right now, guys? What is the audio like at this moment? Is it all good? I'm doing good here in Ascalon, Israel. Oh, wow. You're back to... Okay, you're back home. Okay. Is it showing the book? I tagged it. Is it showing pen products automatically? I wanted to show the book that we're going to be using. So I got it, and I did that, and I did that. And then I'm going to share the live as well, and we will keep going. Okay. I made a goal. My kittens already have 1 month. Aw, they're all growing up. Okay, I shared the live. I hope that many people will be joining here soon. Let me get started with one of these topics that I can talk about from the book, because I think it'll be interesting, and it's been such a long time since we have spoken and talked about some of these topics, so I'm looking forward. They play all day. Yeah, that's how kittens are. That's so cute. Okay, so this book really does go over a lot of interesting things, guys. So I am interested in some of these topics, and so Here, let me show you the book once again. Hi Elsa, how are you doing? So I was showing you the book earlier. So here's the book. Astrophysics for Dummies, a Wiley Brand, Cynthia Phillips, PhD, and Shayna Pryor. So foolish assumption. So I think the book overall has sort of a funny vibe. So A to Z of physics. That's really nice, you know. Like it really covers sort of everything. Courtesy of Stefan Sape and NASA Aubrey Okay, nice picture there of a solar eclipse and whatnot. So a lot of the topics that we've discussed already, we're going to be looking at once again as a review from this book in this author's words, and I think it'll be informative. The 8 planets of our solar system, because remember Pluto is a dwarf planet, so there is that. We've actually used a majors astronomy for majors book to cover a lot of these topics already, but I think sometimes that can be a little harder, and this is going to be a much more easier read. Look at that. We talked about WIMPs, remember? No idea why or how you popped in my feed, but I'm a third-year undergrad at Harvard studying QCD. Well, you are in the right place. We talk about physics and cats in this live session. And I'm also in Boston, like yourself. So we must be connected in some way, as in we have something in common. Physics, astronomy, astrophysics, cosmology, those are my topics here on the channel. And I live in the Boston area. Welcome to the live Temple of Crow. Elsa, Ben, everybody, please do like, share, and subscribe. Okay. All right. So, let's see. Physics and cats. Yes. I love that. Ben is an amazing moderator of this. Oh, you know what? Let's talk a little bit about general relativity, because quantum chromodynamics. So we've actually not talked about QCD too much. So this is a great opportunity to ask questions of Temple to share about QCD, because we've actually talked about QED, quantum electrodynamics, but we've not said too much about quantum chromodynamics. And it's great that we have a QCD person in the chat, and you can elaborate further on your work if you'd like. Okay, so go ahead. Hi, Boga68. Hello, Temple. Hello, Steve. I knew there'd be puppies. Hello, Delaware. Hello, Lewis. How are you doing, guys? So, I know we have quantum entanglement in the title, but you know that along sort of the same era, same century, in which quantum mechanics obviously was making a lot of progress, many advancements, many discoveries in quantum mechanics happened. Earlier on in that same century is when relativity was developed. Special theory relativity, 1905, and then around 1915 or so is the time when general relativity also came out, contributed, of course, by Einstein. And now Einstein is also considered a father of one of the fathers of the old quantum mechanics, where the quantum nature of light was brought forth. And in that sense, he too is a contributor to quantum mechanics, because quantum nature of light was new to us, photoelectric effect, also given to us by Einstein in and around 1905, for which he got the Nobel Prize, because they didn't give it to him for relativity, because I guess they thought relativity was a little bit really, unique, and maybe most people didn't understand it very well. But anywho, he is. We've read from other books and seen how he is actually considered a contributor to that kind of quantum mechanics, or the old quantum mechanics. And then later on in the 20th century, or the 1900s, we actually saw a lot of really what was considered bizarre, and even now some people find to be very bizarre, advancements in quantum mechanics. Of course, one of the topics from which is quantum entanglement, which is in my title today, because I was talking about how Baji the cat is quantum entangled with his sister Suji. But so these topics of relativity and quantum mechanics, these are kind of intermingled, if you will. They're two different things, and they have certain, disagreements, and they've had quite a bit of drama in the past. We've talked about some of this drama, some of these debates between, for example, Einstein, Niels Bohr, things like that. But there is actually, it is good to think about both. So before we go too far, before we talk a little bit about quantum, let us talk about dark energy as a review, okay? Because that is also something that we have covered in the past, but we will review it. Hi, Ben. Thank you, Ben, for the floating heart. Ben has done a gift. Oh, thank you, guys. Thank you so much. I really appreciate it. I made a gift goal, and I really appreciate all your help and support. Mr. Handsome is saying hello. Hello. Hope something amazing happens to you this week. Thank you. Oh my gosh. I hope so too. All right. So because this book is particularly accessible and meant to kind of, make these harder topics a bit more easy to digest, I am looking forward to talking about dark energy as a review from this book, because I think it'll help. So, thank you for working to spread scientific literacy. Thank you. You should subscribe and keep coming to my lives. It's really nice to have supportive people, for sure. And I've been doing this for a few years now, actually. Schrodinger's cat. I've been doing this for a few years, and we have a lot of live streams recorded already and uploaded under the live tab of the channel, covering many of these topics and related topics. Thank you, Ben, again for the gift. And Temple says subscribed. Oh, hello. Hi, Aditya. Hi, DD. From North Carolina. Wow. I went to school in North Carolina. My undergrad was there. Aditya had asked a question that I missed. But thank you for being here, guys. Really appreciate it. I hope you join, subscribe, like, share, all that good stuff. So, why do we need dark energy? We have had episodes in the past where we have talked about the cosmological constant. We've talked about the cosmic ingredients, and we've named these cosmic ingredients. We've named, for example, the 5 cosmic ingredients from this cosmology book that we also have, which I actually own, so I didn't have to borrow that one from the library. This one is from the library. So, and by the way, the books that I had been using from Neil deGrasse, they were so overdue at the library that they were about to charge me fees, but they were very kind. As soon as I returned them, the Boston Public Library just forgives your fees. So thank goodness for that, and thank you for libraries. Thank you to the universe. So the cosmic ingredients. So there is photons, baryons, neutrinos, dark matter, and dark energy. Those are the cosmic ingredients, the 5 cosmic ingredients, where Under baryons, we kind of lump together electrons, although technically they're not baryons, they are actually leptons if you really want to go technical on the particle physics part of things. But baryons are basically, just normal matter, protons, neutrons, the stuff that we're made of, the elements that we're made of. Ultimately, the way you know an element is that element is by looking at its nucleus and seeing how many protons are there, right? And sometimes there are neutrons too in that nucleus. And so this number of protons in the nucleus gives us the type of element. And we know that the Big Bang, which is the origin of the universe, had given us hydrogen and a bit of helium as a gift, but not much of anything else. I mean, nothing at all of anything else. Very trace amounts of lithium, but pretty much the most abundant element in the universe even now is hydrogen because it comes from the Big Bang, and a bit of helium also comes from the Big Bang. And every other heavier element has been made in stars. And then stars have lived and died to make these heavier elements, and also to eject these elements into the interstellar medium and enrich their surroundings. And that's where we all come from. We get major gas clouds from the stuff that is ejected by stars upon their death, and those gas clouds can go on to be birthplaces of the next generation of star or star system like ours, which is how the solar system came to be, and that's how we came to be. So we, all of us, all the stuff that we know and understand really well, or at least more well, is normal matter or ordinary matter, and that is basically the building blocks of that is going to be the protons and neutrons. Okay, so when we talk about cosmology, we take a big step back and look at things a bit more broadly than all these nitty-gritty details, and we say, well, protons, neutrons, though that's normal matter. Protons, neutrons, electrons too. Why not? Because it's a lepton. Technically, it's not really at all the same type of particle as protons and neutrons, but we just say, okay, normal matter. So then this 5 ingredients of the cosmos are photons, that's light, baryons, that's normal matter, and neutrinos, that's also another particle that we know and love, and the last two are dark matter and dark energy. Now, we have talked about dark matter as well in the past, how it is a type of matter which is not thought to be this normal matter. It is this topic of research. We don't know exactly what it is, and it interacts with gravitation. It affects things gravitationally, but it does not interact with light and does not have interactions with electromagnetism. And often the way we see things in this universe or in astronomy is through electromagnetism. Of course, there are other ways too, but electromagnetism is really up there in the techniques that we've used. For example, we can see, stars, planets, galaxies with our eyeballs, just looking up at the night sky, and that is basically utilizing visible light coming from those sources. So if there's no light coming from something, it's quite dark, then it can be hard. But it's not the first time that we have had to deal with such a thing. So even remember, black holes also are dark. There are actually certain objects, brown dwarfs, some compact objects, some other types of stellar remnants, basically, can also be dark, because ultimately a dead star or a dying star or a quite dead star, will also not emit much light. So it's not the first time that we've had to use gravitational methods to kind of know that something is there. For example, along with certain other things that we rely on for looking at and probing the supermassive black hole in the center of our galaxy, Sagittarius A star, we use certain electromagnetic ways, such as we see the neighboring area of the black hole, utilizing ENM. That is, we look for, we can detect X-rays, gamma rays, things like that. But then we also actually see how Sagittarius A star, for example, is affecting
the stars that are orbiting it, and that's the gravitational way of knowing that it's there and understanding certain things about it, like its mass, size, all that stuff. Okay, so it is not, so I wanted to say there are multiple ways of probing in astronomy, in astrophysics. In fact, we live in an era at this point in the 21st century of multi-messenger astronomy. Okay, in multi-messenger astronomy, we specifically quite vehemently want to use multiple types of messengers, not just relying on one, not just like relying on photons, for example, which is light, but also maybe other particles like neutrinos, cosmic rays, and such. And then not just even that, but also gravitational waves, you know. So and we have started to actually do all of this already. So we are actively using detection methods now and for the last 10, 15, 20 years, which include particles other than light, as well as now gravitational waves, which we've also talked about with the LIGO experiment. So, LIGO and Virgo. So all of that is to say that's a bit of a tidbit for you in where we are in astronomy. All of that is to say that we have made progress, but there are still things that we don't know. There are questions that are unanswered. Break the universe's charge neutrality, cause immediate catastrophic if only one. Yeah. So there are questions that we don't know yet the answer of. So, for example, this dark matter ingredient of the cosmos is one of them. Oh, don't do it! Take care of all cats. I hope and pray to this universe that all kitty cats are safe. I'm not. Don't take very good care of the cat and all cats, in fact. Do you like chemistry? I do like chemistry. Oh my gosh, how did you know? Dominic is saying chemistry. I actually double majored in chemistry and physics. Temple is saying lol. Okay, so dark matter is one of those things we are actively researching. I mean, as far as I know, we still don't quite know what it is. And it is one of the cosmic ingredients. Now, dark energy is the dominant cosmic ingredient at this point. And so we will take a look at that momentarily. You should reach out to Star Talk and collab with Neil deGrasse Tyson. Hey, cutie. Oh, hello, Jeremy. So remember those important studies from the 1920s? 1920s were such a rich era, along with quantum mechanics, relativity, already happening, of course, even earlier than the 1920s. But 1920s is also the time of Hubble. So remember how Hubble, for the first time, found certain things, such as the universe is much bigger than we thought. There were many, 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 many more galaxies in this universe than we ever imagined. He actually made observations, experimentation. So I think somebody had mentioned about theories, but you should take a look at what Hubble found in the 1920s onwards to be properly, well, I hope surprised in a good way about indeed the observations that we have started to do now for over 100 years. Okay, so the last 100 years have seen a lot of advancements in observational astronomy and astrophysics. Without these observations, we would really be nowhere. Okay, we would really be nowhere. And even Einstein was wrong about a couple of things, which is totally fine, because being wrong is part of science too. And you do your work, you tell people about your work, you review, you update your work based on findings. But that is to say that, as you might understand, like theoretical predictions can be adjusted based on observations, and exactly that is what happened. So very powerful work by Hubble is what we're seeing here right now. So for most of the 20th century, astrophysicists were confident that they understood the timeline. The essential story was that the Big Bang happened and the universe started expanding. But over time, so see, another just real quick tidbit, the Big Bang and the expansion of the universe are good, like they are consistent with each other. So actually, the expansion of the universe is one of the confirmations of the Big Bang, okay? But then now we'll get into more fun than that. The essential story was that the Big Bang happened and the universe started expanding. Okay? But over time, billions and billions of years, right? Because the universe is, we estimate around 14 billion years for the age of this universe. The gravitational attraction of all the matter in the universe would be enough to slow that expansion down. So, you know, good that it was expanding. But then we do wonder why is why does the universe not collapse upon itself? And this is a question that was asked of Einstein, and it's a question that was asked of even Newton, I believe. Because both of them, of course, are pioneers of gravitation. Newton gave us gravitational theory. We understood it for years and years. I believe maybe a couple centuries or so. I'm getting the exact dates wrong, or can't remember. Like, I know Newton was like 1700s, 1800s. So, for centuries we understood gravitation, and then we adjusted and updated our understanding of gravitation with, with general theory of relativity by Einstein. So both of these people, Newton and Einstein, had to face certain. Oh, good. Hubble is 1889 to 1953. I was asking about Newton actually. Which Hubble was in the 20th century. Like, Hubble's main stuff came out in the 20th century, but Newton is very old, right? Is Newton 1600s or 1700s? I forget. I wanted to say, how old was the gravitation theory of Newton? As in, Einstein was challenging something that was established for centuries. It reminded me of physics class. This is physics class. So welcome. Welcome in, students and teachers and everybody, researchers, everybody. We can discuss. El Hode is saying 1700. 1700. I think that's right. Yeah. I just didn't remember exact dates. Thank you for subscribing. So these people, Newton first, then Einstein, who worked on gravitation, had to face something of a difficult question, which is, why didn't the universe collapse upon itself? Now, granted, they didn't really know how big the universe was. Like I was saying, until Hubble literally showed us with his observations of many, 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 many other galaxies, which he then also classified, by the way, and did so much work, right, to figure out all these things with the other galaxies, and the observations looking at the sky. We had no clue how big everything was, how big this universe really is. But still, that's right. I knew that Newton was born in the 1600s. Sir Isaac Newton, 1642 to 1720. He's so, see, he was so he's so old, like old as in Newton. The entity is very old. 1642. Look at that. So we had, and he gave us, of course, gravitation by the time he was like 24 or something. So young Newton gave us gravitation in the 1600s, literally. We knew a certain something about gravitation, which, of course, which still works, by the way. It still works to an extent. It still works for if you're moving much slower than the speed of light. So, and within regular life, it still works. He gave us that in the 1600s. Can you imagine that guy? And then Einstein updated it and came up with general theory of relativity in the 20th century, so 1900. So centuries. I was right. It was centuries between them, not just a century. So anyway, uh, so these people, these pioneers of trying to understand gravitation, because gravitation is very, very important, because also, of course, it causes all this motion. We see that the moon orbiting around us orbiting around the sun. Turns out, in general relativity, we're all kind of following a straight path in a in a in a four-dimensional space and time. But it also gives us a way to do mechanics and understand about motion, right? And motion is very sort of key and fundamental to physics. Physicists like to know, why is something moving, the time, like what's the equation that kind of describes the state of motion of something, So it was very important to figure out gravitation, but they had to face the question of why do things not collapse? And that is where Einstein introduced the cosmological constant, which ended up being maybe more relevant or important than he realized. Okay, so yeah, engineers have a lot of different words and expressions to probably describe what I'm saying, but laws of motion, the laws of gravitation, these are very pertinent. We want to know how gravity works before we launch a rocket. Like, those people who went to the far side of the moon, like, look at their orbit. Like, they had to do that math. Actually, I haven't looked into it. They might have used general relativity to do the exact, precise equations and calculations to make them, come back to Earth and land here, all that stuff. Um, but that's how well we have to do these things, because when we send 4 astronauts into space and want them to come back and land here in a specific time and spot and everything, that is where we're actually doing a lot with gravitation, right? So because the whole time that they were gone, they weren't really gone, they were still falling towards Earth, because between the Earth and the moon, of course, the Earth is bigger and has a bigger effect gravitationally. So they were still falling towards the Earth, and they had, NASA had to do all the calculations to make them fall correctly, so that they also see the far side of the moon, and then they come back and they're in the ocean and everything like that. So without a proper understanding of gravitation, of course, this would not be possible. And so we thank Newton and we thank Einstein for their contributions to gravitation. But then, what about this expansion of the universe? Why is it expanding? And why is, turns out that the expansion of the universe is also speeding up. So what is going on with that? Hi, young Gonzo. I have been here, but I've been so overwhelmed with the too many projects going on. Can you explain Einstein's moving clock theory? So, yes. So basically, Einstein says, special theory of relativity says that space and time are relative. Okay? So, when you're moving, like, basically looking at the time is light traveling from the clock to your eyes. And if you have a, if you're traveling at a speed close to the speed of light, you will actually notice that you will actually notice that affects your perception of how long things take, and the clock will run slow. Okay, on what do you mean I scared you? So I don't know if I'm explaining it very well, but pretty much that's what it is that the speed of light is a finite constant. The speed of light in vacuum is constant. First of all, it's a constant of nature. It's a constant of nature. It's a constant of nature. And it's finite. So it's not like an infinite speed. So you could imagine going at a speed pretty high, where you're close enough, getting closer to the speed of light. Like usually we're not anywhere near the speed of light, and so so we don't have to worry about this. But let's say if you go at like if the speed of light is c in vacuum, then if you go at like 0.5 c or 0.9 c, you could maybe, right? In theory. And then what happens, right? How do you observe things at that point? Now, even in that kind of reference frame, like if you were actually really going at 0.9 c, the thing is you would still see light to be going at c. It's not like you then see light going at like 0.1 c or something, or 1.9 c. If I'm, you know what I mean? I'm just like doing a simple example. Like it's not like you would see the speed of light changing. So speed of light in vacuum is a constant, and that results in relative nature of space and time. Okay? Exactly. Because time, you know, you need an observer. What I mean, for example, me, I never know what the time is because time is relative. If I look at the clock, I'll know what the time is, but I often don't. And so, I used to be late to everything, and I still am. It's just a thing I have an issue with. And my physics professor, or my physics teacher in high school, was the only one who didn't mind. And he always said that, time is relative. So, what time zone are we? Like sometimes I'm like, people are like, it's so late. I'm like, not in Hawaii. It's very early still. Night is young in Hawaii, So I don't know what people are saying when they're saying like it's late, whatever. But basically, basically time is relative. Okay, like literally, if you imagine a clock, I'm doing the clock's arm moving, and you see that it's literally light traveling from that clock to your eyes, and that's how you know what time it is. And you're going to notice certain differences if you're yourself moving at a very high speed, close to the speed of light. And that's it, because light is still traveling at the speed of light. Whether you're traveling slow or fast, light travels at the same speed. So you notice certain observations to be different or relative. And that's literally all of special theory of relativity. It just gives us space-time relativity and mass-energy equivalence, okay? So that's what that is. And then it's been expanded to also explain gravitation. So because space-time, this special theory of relativity is for inertial frames, as in you're either at rest or moving at a constant velocity. Now, if you want to understand gravitation, sounds like fiction? No, this is fact, and fact is more interesting than fiction. If you are now accelerating, for example, we do under gravitation, how to explain that, right? So Einstein thought about it, and he was very clever, and he postulated that in a broader theory, which is the general theory of relativity, and he explained gravitation with that, okay? So hopefully that helps whoever asked about that. Wouldn't your body just rip apart if you're going that fast? Isaac Newton, I've heard about you. Hello, Juan. Hello, Milo. Hello, Ben. Thank you for the gift. Oh my gosh. Thank you, Ricky. Ricky has sent. Oh, these are some good questions. She kinda cute though. Oh, hello, LKO. Temple of Crow. Science is indistinguishable from magic if you don't understand it. Science is very magical. Thank you so much for the gifts, guys. Thank you so much, Ricky. I'll do another goal. I think my goal ended. Thank you so much, Ricky Mathias, for the gold coin. And I'll also shout out my top fans really soon here. Thank you guys. Is this related to Einstein's moving train? Like, yes! I always had some difficulty understanding it or putting it into simple examples. Exactly. Writer has asked, is this related to? Yes! Einstein's moving train and lightning strike theory, all of this is special theory of relativity. Einstein was actually thinking about racing a beam of light. So in his thought experiment, he thought about racing a beam of light. And what happens? What happens? Right? So I don't know what your body will be doing. Maybe it'll rip, maybe it won't work, things like that. But if you are going uh, that fast and you're trying to race a speed of light or a beam of light, what do you observe? As in, what do you think is the speed of light in that situation? He thought about that and he thought about that. And pretty much the nice thing was that he's also a very good student. Einstein, if you ever thought he's not, then you're wrong. Einstein is actually a very good student. So he had studied, of course, the Maxwell equations, the ENM, electromagnetism, the theory of electromagnetism that comes before him, that, was happening when he was younger. And he also got that the speed of light is a constant from those equations. It falls out of the Maxwell's equations. So then he's putting that together with the insight that he is coming up with in order to give us a better explanation of light, and finding that, oh my gosh, even if you are racing a beam of light, you actually observe the speed of light to be the speed of light. Same speed. Speed of light is a constant of nature. So then what that means is that it has some repercussions in your how you observe things, like how you observe a length or time. So time will move, will go slower, length contraction will happen. So those types of things, it's basically the length contraction in the direction of movement. Length will contract. Length contraction and time dilation are simply just falling out of that fact that the speed of light is a constant, even when you do crazy things. You could do crazy things. You could move really fast, and the speed of light will still be the speed of light. Okay? The only time the speed of light is not the same as the speed of light in vacuum is when you're in a different medium. But that's a different story. So in a different medium, speed of light will have a different speed. It'll be slower. But let's say in vacuum, right? You'll still see the speed of light to the speed of light. And it sounds very simple, and it is, but the insight he got from it is where the genius lies, okay? So that's where he is a genius, because he gave us a profound insight from that simple fact. So anyway, that is relativity. So, and then that, of course, got broadened to include gravitation in the form of general relativity. But the question remains about this expansion of the universe. So I'm giving credit to all the people who have worked on gravitation, of course, as you must. In physics, it takes some time to get to the point of the story, because you want to also say everything that is related, but sometimes there is not enough time. But indeed, you must always give credit, because all of these giants are the shoulders we stand on, and we must understand what they have done already in order to proceed and do the next batch of things. Okay, I was in the right spot. I will. Okay, let me do that. Okay, I created another goal, and thank you so much for your gifts. Temple is saying sciences. Hello. Hello, Peter. Does physics say anything about ghosts? Not that I, not that I know. Hi, Neutrino. I'm glad you're okay. Thank you. Hi, Tyrone. I missed you guys. What's happening? Been busy. What you touching base on? Gravitation, quantum mechanics, and dark energy. Where are you, dear? Because I'm from Russia and I have a bear. Hello, Unstoppable. Welcome, everybody. Thank you for being here. Satisfy the equations of, well, moving the tachyons are theorized to have imaginary mass. I know it's been so busy and I got a little caught up and overwhelmed, but I really appreciate you guys and I hope that you give me your continued support. It doesn't change mass. I deserve a wagon, like a car. The closer to speed of light you get, the more mass you gain, right? Speed is relative to goober. Are you contracting right now? Are you contracting right now? Hello, the commissar 4248. Yes. I do contracts. I do work on a bunch of contracts. I don't know which ones you're talking about, but what's your astrological sign? Hello, commissar. My sun sign is Libra, my moon sign is Libra, my Venus is in Libra, and because I have to mention other things too than the sun. My sun is in Libra, my moon is in Libra, my Venus is in Libra, and something else is also in Libra. So I'm huge on Libra. Then I have a bunch of Capricorn placements, and I have a Scorpio in Pluto. I have my Pluto is in Scorpio. So I am a Libra, Scorpio, Capricorn, Gemini mix, actually. Hello, Rahul. Why are you so pretty? Explain, please. Oh, that is actually a topic that I know very little about, which is genetics, biology, genetics. I think it's just some very complicated biology. You ever done something strange? Hello, Titan. I like your name. Titan is one of the giant moons of this solar system. I would like to request to see your ceiling fans. So I actually don't have any ceiling fans. I don't. I can show you my ceiling in a bit here, but I'm thinking, and I don't have any ceiling fans. It's Boston. We only get summer for like a month. None of that means anything. Okay. Hello, Slime. I like your change and strange question. Strange reminds me of a quirk. Oh, and somebody had asked about a quirk. What is Libra, Libra, Libra? Hello, Flames. Somebody asked about a quark, I believe. We can talk about that too. A quark is a type of particle. It is the building block of protons and neutrons, which are in the nucleus of all the elements. Hi, Angel. Shalom, everyone. You're a Capricorn. It's fun. I'm too smart to believe in astrology. Whatever. Why not? You don't have to believe in it, I suppose, but you can have fun with it. And why not? Sure. It's a study of something, and I am a student of many topics. So the science is not the only one. At what? Hi, Fidel Torres. Hello, my dear. At what age did you realize you was very smart, unique, and gifted? Um, I don't think I realized that. I think I wanted to do unique things, but I did not think I was very smart for sure. I actually thought kind of the opposite. Um, yeah, astrologers, which is very different, which is not the same as astronomy. So sometimes in this channel, people think of the physics as psychic and astronomy as astrology and cosmology as cosmetology, which can be funny, but of course not the same thing. But astrology is a study. People do spend time studying and looking at things and making sense of something, and why not? So let people be and have fun. But astronomy, of course, is a science, and getting back to that. So, the essential story was that the Big Bang happened and the universe started expanding. But over time, billions and billions of years, the gravitational attraction of all the matter in the universe would be enough to slow the expansion down. That theory changed significantly in 1998. So, that is when actually we found out that the universe's expansion was not only expansioning, but also uh, accelerating. When observations with the Hubble Space Telescope of extremely distant, far, far away supernovae showed that way back when these supernovae happened, the universe was actually expanding more slowly than it is today. So, this data set, by the way, we have talked about already multiple times. This is a very important piece of information, a very important study that was done by competing groups, so multiple groups, and what they concluded is very important in our understanding of dark energy and the expansion of this universe. So it really, shook things up. Um, Astronomy is the science one. We cannot understand you. Aw. Nice to catch you, Space-Time Entanglements. How are you? I don't know what that is. Is that a show? I didn't really watch much TV when I was growing up. So, 1998, this data set that they looked at of many supernovae, um, this is what really shook things up. This means that contrary to popular belief, the expansion of the universe was actually speeding up, not slowing down due to the force of gravity. So, gravitation is contributed to by normal matter, dark matter. All of that was not actually making the universe slow down its expansion, but it turns out that the expansion was accelerating. Okay? Now, one of these supernovae actually is in the book, the picture of it. So I can show you at the end, or I can take a picture and show you. The bottom right image is a different image that shows a new bright star appearing between an observation in 1995 and one in 1997. That is supernova 1997 FF, which is about 10 billion years old. So she's kind of going through and explaining some of this data. So, how could the universe's rate of expansion be increasing over time rather than decreasing? An undetermined force must be responsible for that increased rate of expansion. This potential solution came to be known as dark energy. And its best explanation we currently have as to why the galaxy's expansion is accelerating. So, I think she means the universe. It's the best explanation. This dark energy explanation is the best explanation. We don't have another. I mean, even dark energy, we don't fully understand, and there are many experiments and surveys observing even more data and getting even more data to understand this. Okay? Okay. cosmic web. Space-time entanglement is cosmic web. Okay. Well, I like both of those names. Okay. So now, another question that we often get is, are dark matter and dark energy the same? Confusingly, no. They're not the same. They're quite different. Dark matter is the name for the invisible substance responsible for keeping galaxies together, whereas dark energy is the force that pushes the universe apart. So dark matter contributes to gravitation. It's something we don't fully understand, but it is there, and it interacts gravitationally. But it keeps things together. Dark energy is responsible for the expansion and the speeding up of the expansion of this universe. So can we get 30 likes? Okay. So they're quite polar opposite, but the names can be confusing. You can have a conversation in the chat, no worries. In the Big Bang discussion, you learn that the universe began with an explosion at a singularity. So I'm glad she's talking about this in a nice, simple way. And then started expanding and cooling. So very hot, very energetic, very dense in the beginning, the universe. And then it started to expand, it started to cool down. We got neutral atoms at some point. Much later, much later, we started to get the first galaxies, blah, blah, blah. But the universe, the key here is the universe began expanding and creating space right after the Big Bang. The fundamental reason for the slowing down of this expansion is the gravitational attraction of matter, as predicted by Einstein's theory of general relativity. Astrophysicists now think that there was a transition period between 9 billion years ago, around 9 billion years ago. Dark energy began dominating the universe. So something else we've kind of talked about quite a bit is actually the universe has evolved, and the universe is evolving, right, currently. Thank you for the star. Thank you for the gift, Slime. Or Slim. So the universe has not been the same forever. Oh, I love that. Oh, was that a turtle? Thank you. Oh my goodness, stay hydrated. I love it. Very true. I should go get some water. Good reminder. And I loved that turtle. That was so cool. Aww. Thank you guys. Thank you. Nicole Han is doing a flower. And then Slim Slime has done a 6 and a 7. I'll give you a million likes, but I'll wear my finger down to a stump, tapping my screen. Yes, please tap the screen. Give us some taps on the screen to give us likes as well. Thank you. And the hearts and whatnot. Thank you so much. I have never seen that stay hydrated gift before. I had never seen it. That was my first time, and I love turtles too. I just stopped in my tracks looking at that turtle and the hydration. Thank you. Oh my gosh. If you're new to the channel, please like, share, and subscribe. Thank you. Nicole, thank you so much. Thank you. Thank you, Slime. Thank you for the sparkles. And the pepper. Thank you, guys. So, and also please do subscribe. I love to see some new people joining the channel. Okay. So kind of you. Hi, Mr. Vision. Okay, so the universe has been changing, it's been evolving, and it is not doing the same thing. Oh my gosh, I had a goal and you completed it. Maybe dark energy is created through the expansion of the universe in itself, aids in the actual universe, creates dark energy. Yes, that is actually a great point. That is actually a great thought by Ryder. This is very true. That may just be the case. Thank you guys so much for my goal completion. I'll make another one. But thank you. Thank you, Lions, liked and subscribed. Just wanted to be number one. Oh my god, let me do the top fans. Number one is Slime. It's true. Slime is number one. Number two is Ben Abraham. Number three is Temple of Crow. Number four is Tyrone. Number five is MGA. Number six is Peter Coy. Number seven is Spacetime Entanglements. Number eight is Ryder. Number nine is AII. Number 10 is Mr. Vision. So indeed, you are number one. Do a flip? I can't. I cannot do flips, I'm sorry. Or are you asking me to flip my spin? Like a particle. I can try that, maybe. Just maybe. I really need... Can we get 10 more subscribers? Okay. Where is... Thank you for helping me complete my goal. Hi, Puzzle. Are you East Indian? Yes. That's a great guess. I do not live in South Carolina. I'm not in South Carolina. I am from the eastern part of India, and I am on the east coast of this country now, US. Hi, Ivy. Happy birthday. Birthday today. Birthday girl. Okay, so we think that there was a transition period around 9 billion years ago where the universe kind of changed. The universe has been evolving. It has not been in the same kind of era throughout. So there might have been, we actually think that there, the beginning of the universe, during the beginning time, we think it was a radiation-dominated universe. Then maybe a matter-dominated universe. And at some point, it flipped to becoming a dark energy-dominated universe. Happy birthday! Mazel tov. Congratulations. So, dark energy began dominating the universe at that point, which we think is around 9 billion years old of the universe. At that point, the expansion of the universe started accelerating instead of decelerating. The observation of supernova in 1997 FF, as discussed, why do we need dark energy, is from roughly 10 billion years ago. Oh my gosh, Nicole has done a super chat. Wow. Yay, congratulations on your goal. Woohoo. If you're new to the chat, please like and share and subscribe. Thank you very much. Can everyone please double tap that screen? Nicole, thank you so much. Oh my gosh. Nicole, you're the best. The way you structure your sentences clued me in. Thank you, thank you. I appreciate that this is helpful. So, something changed. I mean, the universe has been changing. If there were not changes in the universe, we would not be here, right? Because in the beginning of the universe, remember, there were no galaxies, and remember, galaxies and the stars within galaxies,
The first clumping of matter, which led to the first galaxies, the first, stars, suns, pretty much made the heavier elements, which then went on to make us. So there would be no us if the universe was not evolving constantly. Even now, it's evolving constantly. So it has gone through various different eras. At first, at first, the photons were very important. Photons were king of the jungle, is what I like to say about the early universe, for example. But then things kind of calmed down, things got cooler, and matter started being more important. And then, around 9 billion years later, this dark energy situation started being important. And we went towards more acceleration than deceleration of the expansion of this universe, which is a puzzling thing, and people would love to know more about dark energy and precisely why there are so many experiments and efforts even now currently on this topic. There were not. So we actually have a baby picture of the universe. So we have a cosmic microwave background baby picture of the universe. So we actually know what the universe looked like before galaxies, believe it or not, which is really cool. And that is why we have entire episodes on this topic of the cosmic microwave background. Some leftover photons from the early universe actually tells us what the universe was like. And that's a whole nother topic. And pretty much because of the cooling, and also there was this last scattering, and that's where this we get this image of the universe from that time, of around when the universe was around 300,000-400,000 years old. And there are actually little itty bitty irregularities, or what do you call the what's the word for when you what's the word when you go a little away from deviations, right? There are little deviations from being completely homogeneous, and so little non-homogeneities in that smooth picture of the universe is ultimately pretty much says that gravitation was being given the green signal to dominate in certain little spots. And if gravitation did not win in some parts of the universe, then we would not have any galaxies. So clumping happened, matter came closer together, we had the first galaxies, we had the first stars, we started doing all that stuff. So then that happened, and we started to make the beautiful galaxies that we now, one of them we live in, we know about other ones. And so definitely there were no galaxies before. That's the answer to that. We actually have a picture of the universe that shows us that there were no galaxies. So the supernova from 1997 that they're talking about here predates the transition period when the acceleration of the universe began to slow. The dating here is key, and it explains why the measured acceleration from 1997 FF, so it's observed in 1997, but the actual thing happened before. It explains why the measured acceleration from 1997 FF is slower than the measured acceleration of more recent astronomical objects, ones that are closer to us. So farther away and then closer to us. So there's a diagram here which is showing that pretty much it's showing the expansion of the universe with a change in expansion rate. So the expansion rate itself is changing and is becoming different at about 9 billion years, okay? No, as the universe cooled in the past, so at around 3
to 400,000 years old, when the universe cooled and made the first neutral atoms. After that, we actually got galaxies. So so locally, in local spots, we got, and by local I mean, at cosmic scales local, we started to get galaxies. So there was gravitation winning in spots and galaxies forming, because if things don't come close together, then there's no galaxies forming, and there's no, you know what I mean, like there's no stars forming, there's no structure forming in that sense. But then at around 9 billion years old of the universe, we notice a change where the expansion rate is changing, and we get more acceleration of the expansion. And we say that this is a new era of the universe where the expansion is dominating, and something called dark energy, which we don't fully get, that's dominating now. Okay? Because basically it's an anti-gravity term. It's an anti-gravity phenomena, dark energy. If there's more gravitation, we will collapse. If there is more of the dark energy, we will keep expanding. There is a sort of balance, right? And there are various cosmological models. Actually, you can like compute all this and come up with models that kind of say, oh, this model shows us kind of collapsing. This model shows expansion, but just enough expansion to not collapse. This model shows expansion, but so much expansion that we're like more expansion than what's observed. So you can kind of play with that balance of gravitation and anti-gravity and figure out where this universe is, right? Because in your model you could have like 3 or 4 different types of universes, literally, and only one of them will probably match with what you observe. And then we can narrow down and be like, okay, that's the universe we live in, with these types of numbers and these types of constants and things like that. Right, and also, by the way, if the expansion rate keeps increasing, things, we keep on expanding and there will be parts of the universe that we will never, and there's already parts of the universe that we will never see. So this was a disturbing thought that we came across, which is that there are things that are disappearing into the distance, literally as we speak, and we'll never see because it'll be too far at some point, and light will not reach us. Yes, there is a, so we'll talk about that, but yes, there is a model. The model, there is a model that you can still play with the other models because it's research, but there is a model that pretty much is closest. Closest with the observation. Okay, so let's keep going. This shift between decelerating and accelerating expansion is relatively solid proof for the existence of dark energy. So slowing expansion versus accelerating expansion. So the universe, remember, was already expanding. We know that from the Big Bang. If the universe had not expanded, we would not have the cooling, which was very much needed to then, do the thing where we got neutral atoms, and then down the road we got our first. So it's always a balance. To make a galaxy, you need things to come closer. When things come closer, there can be thermodynamic effects, and you can start to get hot again. Like, for example, a star formation is a bunch of gas, a nebula, parts of it are coming closer and creating a different thermodynamic environment, which then forms a star, which is going to be really hot, right? So the universe was cooling, but and matter was dominating, and in some spots we got galaxies, we got structure, which is large scale structure, which is really like hard to imagine, right? It's like the entire universe getting large scale structure. And then, but thankfully we don't have to imagine, we can actually measure and have pictures of all this. um, but then locally inside the galaxy and then inside a sun or a star, actually, like, you want things to both cool and then become hot enough to like actually make a star. So there's a lot of cooling and heating happening, you know in turn, basically, like first the cooling then the heating. Okay, but at the same time the cooling of the universe does come from, has been happening from the beginning, from its origin, which is because, and which is why we know it's been expanding. We know it's expanding. And um, we used to have only like nuclei in the past, like close to the Big Bang, close to after the Big Bang. We only had nuclei. We didn't have neutral atoms. Like things about uh, things were not uh, cold enough to make an atom. You know, so that happened later. So we know things have been cooling, things have been expanding, but at some point we're thinking that this expansion should be slowing, not that it's just drops, but should be slowing. But we find instead that it's speeding up. Hello, Nicole. Thank you for the gift. Hi, Pumbafo. Hi, Milo. We're talking about the universe and cosmology. Hi, Grady. Yes. The heat left over from the Big Bang is currently, so photons left over from the Big Bang is currently very cold, averaging about 2.7 kelvins. So barely above absolute zero. Thank you, Nicole, for the star. Oh, I'm glad I looked up because that's really pretty. Thank you so much, Nicole, for the stars. Oh, thank you, guys. My goal! Nicole, you did it. Oh, God. Oh, thank God. Sometimes the app kind of freezes up and it worries me. Hi, Bay Boy. Hi, Jeremy. Thank you, Nicole. Oh, I really love the sparkles, actually. They're so pretty. And that turtle. Let's see that turtle again. That's drinking water. Do you think that the Earth landing in the Goldilocks... It's a very interesting question. To support life and make intelligent enough human beings or living beings to be asking that question about the Goldilocks zone, the Earth had to be where it is. So, uh, you know, it feels a bit. I know that sounds like a circular thing, but basically, I guess we can thank the universe that Earth is in the Goldilocks zone, because if it weren't, then it would not be friendly towards supporting life, and we would not be here asking that question of uh, the one you asked, Jeremy. So I really love Earth. Second favorite is Venus. for me. Venus, I feel bad because, Venus could have had it. Venus is much like Earth. Earth was kind of like Venus before our atmosphere got cleaned up because of oceans, you know? So, Venus, unfortunately, because of its position being too close to the sun, does not have oceans, liquid water. So, it did not clean up its atmosphere like we did. So, we are in the Goldilocks, and that's why we are here. We can't be, we can't live on Venus. Thank you. I will set another goal. Good luck, Tyrone. Intelligent design. You think somebody designed all of this? It could be. We are just tiny humans. Is that a purple jacket you're wearing? Purple fits you beautifully, Baji. Oh, thank you. Yes, it's a house coat. Like a comfy, plush, comfy, dressing gown type of thing. They are magnetic and relativistic, containing particles. Okay. Do I think Pluto has life? Thank you for all the gifts and super chats. Thank you for the gifts and super chats. I really appreciate it. In fact, I think for the month I need like $20 more to get paid by YouTube. So I really appreciate all your support because there's a threshold before they send you the money. I heard from a scientist that men are from Mars. I don't know about that. I don't think, maybe men are from Mars. I don't know. I really appreciate you guys. Apparently men are from Mars, guys. It very well could be the case. It very well could be the case. Thank you again, Nicole. I really love your gift and your super chat. Really helps me out. Where is the button for gifts? I'd like to think more like the design. Travel to Spain? Did I go to Spain? I don't think I went to Spain. Let's reach those goals. Yes. It is true. I have a soft spot for Venus. I have a soft spot for Venus because it is actually more similar to Earth in many ways. And so I really like it. I really like it. Oh, I could have done it from here. I'm struggling for no reason. There. I made another goal. I was trying to look for it on the laptop, but I could not find one. And there, I've started a new goal. Thank you so much, everybody, for your support. You are rocking it. You guys are killing the goals tonight. You guys are doing so good tonight, I must say. Nicola, my love. Thank you, honey. Thank you, ma'am. All of the things. Oh God, what is happening? Can I cross this out, please? Did you kill the goal again? Goal achieved! Thanks to the participants. We achieved our goal. Nicole, my love, you've done it. You've done it. Thank you for your extreme kindness, I must say. Oh, thank you guys. Thank you, thank you, thank you. I really appreciate it. I needed a little boost. Okay, let's keep going. My laptop has frozen. It's fine. So, this shift between decelerating and accelerating expansion is relatively solid proof for the existence of dark energy. Astronomers, are things working? Things are not frozen. Is it? Because I see that my laptop is kind of frozen, so maybe I'll close it. My phone died. My laptop froze. I hope that you're still here. Thank you, guys. Oh, thank you, Nicole. Nicole, I can kind of see your profile picture. So pretty. Nicole has achieved the goal again. Water woman. She just achieves every goal. Thank you. Thank you, thank you, thank you. So, astronomers using the Hubble Space Telescope measured dozens of ancient supernovae in an effort to continually refine our knowledge of cosmic expansion rates. And they are starting to be able to map out approximately when this transition took place. One possibility for the timing of this transition is that it occurred when the early universe's matter spread out enough that gravity no longer had the upper hand. Because remember, if gravity never had the upper hand, then we would not get the galaxies and the stars and all these things that we love. You need some times for gravitation to win, right? And it did, and we see the distribution of matter in this universe, and we also think that dark matter might have helped in forming these galaxies and gave the normal matter a hand in clumping and making the first galaxies and whatnot. And even now, there's dark matter even in this galaxy. So they do play a role, and as we understand dark matter better, which is another topic, hopefully we understand that better too. But large scale structure, distribution of the matter in this universe is not random. It is something that there's some reason, rhyme and reason behind it, and dark matter plays a role in that probably. So thank you. Hi, Shrey. Oh my gosh. Nicole gave me a makeup brush. Thank you so much. Thank you, Nicole, for the brush. Thank you, thank you. Shrey, how are you doing? Hello, my friend. Absolutely. Send a makeup brush. I love it. I missed the makeup brush because I wasn't looking, unfortunately. I started another goal. You guys, thank you so much. So, astronomers using the Hubble Space Telescope measured dozens of ancient supernovae in an effort to continually refine our knowledge of the cosmic expansion rates. And they're starting to be able to map out approximately when this transition took place to getting the expansion rate to be more. Thank you for the star. One possibility for the timing of this transition is that it occurred when the early universe's matter spread out enough that gravity no longer had the upper hand. After the universe had grown large enough, dark energy could take over. So yes, somebody had mentioned that the more expansion you get, the more expansion you get, right? So Scott, hello. Scott is here to do a gigantic super chat. Scott, you're gonna help me meet my threshold for the month, as I am a passenger princess, as Scott has pointed out. We have missed you. I hope you like the live, share the live, tell all your neighbors, all your friends, lovers, husbands, wives, everybody about this live and continue to join and keep coming back. And Scott will now be sponsoring this live. I believe in you. I believe in you. So far, let's see. Top fan right now is Nicole. Oh my gosh, that's such a pretty picture, Nicole. I love it. Thank you so much, Nicole. Nicole is the top number 1 in life and this chat. Number 2 is Slime. Number 3 is Ben. Number 4 is Milo. Number 5 is Temple. Number 6 is Tyrone. Number 7 is MGA. Number 8 is Milo again. Another Milo. Number 9 is Peter. Number 10 is Spacetime. And Shrey is one of my members. So kind of you. Thanks, hon. Aww. Been busy, boo. Aww. Well, me too. It's been quite rough, actually. I've had too much going on. I've had so much work, which thank you, God, and thank you, universe. But yeah, I've missed you guys. Thank you for coming, Scott. So, we've been talking about gravitation, general relativity, what do you call, dark energy, all that stuff. I think you'll like it. And hopefully you'll catch the beginning part later, Scott, whatever you missed, okay? So, the more expansion there was, at some point, expansion kind of took over and started to win. And as it starts to win more, okay, is what we think. Because, yeah, we're seeing that the expansion has sped up. It's speeding up. It's actually accelerating of this universe. So, on the smaller length scales common in our solar system and galaxy, gravity still dominates. So, I wanted to make this clear. In the local universe, as in, say, our solar system, obviously, right? Like the moon is still going around the Earth. We are still going around the sun. The sun is still going around the center of this galaxy. So gravitation is important at those scales. So gravitation is still winning at those scales. But at the larger scales of this entire universe and, farther away from us, we actually are seeing dark energy winning or expansion winning. And not just that, the more expansion there is, the more expansion there is. The farther out you are, the faster it's receding. I hope that makes sense. Okay, so the more expansion there is, the more expansion there is. If an object far, far away from us is seen to be going farther away, it does so faster than something a bit closer. But we're not to confuse this with our local universe, which is our galaxy, our solar system. In this range of things, in this type of scale, or even our neighboring galaxies, okay? Even our neighboring galaxies. At that type of scale, we see things coming together. We get closer. We at one point we said that our galaxy will collide with Andromeda. Turns out probability of that is actually less than what we thought, okay? But all of that is to say that gravitational effects, because there are other galaxies too. There's the Large Magellanic Cloud, and there's other galaxies in our neighborhood, in our neighboring cluster. So we belong to a cluster of galaxies, right? So in our local cluster, gravitation is winning, as far as I know, anyways. I believe that's the case. I mean, we wouldn't be much of a cluster if we were like flying apart, right? Cluster, by definition, means we're clustering. Matter is clumping. Matter is held together by gravitation. But then, larger scales than that, we're seeing expansion. And not just that, this expansion started to win at some point. The evolution stage of the universe actually changed. It used to be matter dominated. Now it's dark energy dominated. And it started doing that at around 9-10 billion years old. Okay. So. It's important that I keep having to start goals because Nicole is just achieving all of them. thanks to the universe, and thank you for creating Nicole and everyone else here. So, that is a great question. A photon can travel forever, but if it meets with something else, like another, like a particle, some other thing, then it can. Oh, I'm not at all bothered when I'm interrupted by gifts. I am not at all in the least bothered when it is your gifts that are interrupting me. So I love it. So it depends on photons can actually interact quite a bit with other things. You have a physics exam. Good luck. Hi, Hind. Hind. I like that. I love you. Thank you, Jose. Nicole, I wish you could start the gifts. Who's winning? Probably Nicole. Scott! As soon as I said that Nicole is winning, which she sure is, my heart, Scott has also won my heart with a gift or a super chat. Scott has come back to do a super chat in order to sponsor this live. Thank you, Scott. Oh my gosh. So now Nicole is number 2 now, only because Scott is number 1 with his generous super chat. Thank you so much, Scott, indeed, and Nicole and everybody. Scott is number 1 because I'm the passenger princess, and I heavily suggested that he sponsor this live, but also because he's very kind. Thank you, Scott. Number 2 is Nicole, my love. Thank you so much. Number 3 is Slime. Number 4 is Ben. Oh my gosh, Ben. Thank you so much for your support. Number 5, Jeremy. Hello, Jeremy. Thank you for asking such great questions and being such a sport. Number 6 is Milo. Number 7 is still Temple. Number 8 is Tyrone. Number 9 is MGA. Number 10 is Milo. But anything could happen. Anything, as we saw with Scott and Nicole. Things can change around here. Hi, Zanini. How are you doing, darling? Oh my gosh. Oh. Floating Sun said, what do you think about next Artemis? Are we going to land on moon? I mean, maybe. Scott is saying as always though. Did I say as always? Like you that you are the sponsor usually? Well, we have missed you, Scott. I hope that you're getting richer and richer at your job because you have a great responsibility with with these lives, and that is to support the passenger princess. Told you Scott owns all of the paper towels. Hello. Let's make this smart pretty lady rich. Thank you, Zanini. I really appreciate all your kindnesses. Thank you. I'll travel the universe with you by my side. Aw. Dark matter is moving me further down the list. Actually, Scott and Nicole and Ben are all made of normal matter. Last time I checked. So it's actually ordinary matter that is moving you further down. Nothing extraordinary. Do I play chess? I do, but I'm quite bad at it. I'm not good at games at all. Thank you, Nicole. I've installed a lot of them. Hi, Michael. Mikhail. Hi, Jones. Mikhail, how are you? I'm speed like tachyon. Hello, Mikhail. I've installed a lot of them. What do you mean? You've installed a lot of what? I'm looking at the comments. Oh, paper towels. You're a boat. This is so fun, guys. Thank you all for coming. Nicole with her gifts and just, what's the word? Just obliterating all the goals. Scott with his super chat. Nicole also did a super chat, I believe. Correct? She is number 2 for a reason. And everybody for your gifts and all your kindness, support, love, hearts, emojis, and comments and participation. Really love it. Scott's brand. Scott, do you have a paper towel brand? We could mention it here while we have a chance. Thank you, Nicole, darling. Oh my gosh. Nicole, it is Nicole and Scott's night. It is. Milo did a turtle with the water. Oh my gosh. Milo. That's like one of my favorite gifts, I would say. It's pretty much one of my favorite gifts. That turtle drinking water. In fact, I should go get my water bottle. So we are at the end of a section here. I'll just say to close this out and wind down and go get my water and chat with you casually here. Dark energy makes up around 68% of the universe and is responsible for the accelerating rate of expansion of this universe. So that's a really big deal because of its dominance of the energy density of the universe, with its, almost 70% makeup of the universe, and because it's responsible for our accelerating expansion. It's obviously very important, and we would like to understand it more, and research is ongoing, but that's the motivation. Where does it come from, and what is it exactly? We are asking that question and trying to answer it. Astrophysicists have come up with a number of possible theories, but these are theories and we have to probe further to really understand this. Okay? We don't know exactly, right? And it is a top mystery. I would say the number 1 mystery is dark energy, number 2 is dark matter. So astrophysicists have, there's some possible theories. Empty space has vacuum energy. So number 1 theory is empty space has vacuum energy. There's some energy of the vacuum, right? It's kind of mysterious and kind of not really, super clear, but there is some vacuum energy, and so we call this thing dark energy. That's causing this. It's kind of like the thing that would cause pressure and collapse things. It's kind of like the opposite of that. It's a negative pressure, so it expands things. So empty space has vacuum energy. Space has virtual particles as a result of quantum field theory. So this is where, remember, I mentioned at the beginning of the live that it's very important to remember, as we talk about relativity and all of this stuff, that there's also quantum mechanics. And we started with Baji's quantum entanglement with Suji. That was sort of, alluding towards the fact that we have to take into account quantum mechanics at the end of the day. We have to understand what contribution to all of this mystery does quantum mechanics have, because without that, probably we are not going to get the full picture. So quantum mechanics is very important. We will continue that next time, but space has virtual particles as a result of quantum field theory. These things, they are sort of these things. They might not be things in the sense we usually think of things, but there are maybe things that are causing this negative pressure. Space is filled with an undetectable energy that acts like a pressure. That's another theory. Dark energy is created by faster than light particles called tachyons. This one I really don't know much about. The treatment of gravity in general relativity needs an extra term. That's the last possible theory. I wouldn't really go with that one as your first thing, um, because general relativity has so many successes, and predictions of general relativity have been coming true for a century since its birth. So you know, sure, maybe that there is some adjustment needed there, but it would not be the first avenue that I explore. So these might all seem like strange explanations. To be honest, you're officially now at the point where astrophysics gets mysterious. Being scientists, though, astrophysicists do have some evidence for many of these theories and have also worked to pull the idea of dark energy together with the rest of our understanding of the universe into a standard cosmological model. So somebody asked about the model that's right, and this is that. Okay, so we'll get into this model and kind of what goes into the model next time. Einstein, cosmological constant, dark energy, quantum theory, quintessence, this five things pretty much. Tachyons, moving faster than light, questioning GR. We will talk about all of that. So next discussion will be very important because in simple terms, we're actually going to get into it. In the past, we've talked about these, but in a more dense, too much information kind of way, probably from another book. I used a standard, grad school level cosmology books. That's the one I had. But now that I have this book that I got from the library, I think it would be good to review all this from this text. Okay, so once again, this is Astrophysics for Dummies, by Cynthia Phillips and Shana Prywer. They co-authored this book, and because we're at a good stopping point, we will stop this, but we'll keep chatting, take any questions, thank people again. Evil Orange Twin. So Neil deGrasse's books are back at the library. We kind of finished those. I think, Scott, you missed some of my lives. So we actually went over a lot of what he wrote. Like, we kind of covered a lot of the main concepts that he talks about. So we had 3 books from Neil deGrasse. I made a new goal, more ambitious. I'm trying to expand here as well, thinking about dark energy. So we covered a lot of the concepts that he talks about a lot, including, of course, also dark energy, dark matter, astrophysics. There was a book that we were referencing a lot. It's called Astrophysics for People in a Hurry. And then there were like 3 total books that we looked at. And it was very nice. But then they were super overdue at the library. I had, I think, over $70 of fees on them. And so today actually, itself, I returned those books and got those fees canceled at the Boston Public Library. Thank God for that library system. And got this book, which is Astrophysics for Dummies. And that's not my language. I don't call people dummies. And I really don't think that, I think that's just a title that people give. But these are, good things to understand in simple terms, in a readable kind of way. Not necessarily dumb, right, at all. So, so we will continue this. And in fact, I'm quite encouraged because she goes over the main concepts, in a good way, without getting it being too difficult. So I really, really like that. Do you guys know the dummies came up with It's quite humorous, not falling for it. Oh my gosh! Are we almost at the goal? Who wants to do the 50th gift? Nicole being hot with 49 sparkles. Nicole's temperature, gift temperature, is really high. She has been most supportive. OMG, Nicole. Nicole, let's see if someone else wants to do the 50th gift. Nicole is so kind, but give her a hand, somebody. Let's add one more. Nicole, you're the best. My mods, Nicole, Ben, you know, Scott, my super chat donation person, sponsor. Hi, Cloaked. Hi, Zeus. Hi, Mr. Vision. Space-time entanglement. If you feel something tickling your toes, that's me at the bottom of the list. Space-time. Do you guys know how the dummies... Okay. Black holes. Hi, Anthony. So, we didn't talk about black holes too much this time. We mentioned it briefly, but we're talking about more dark energy stuff today. And I named the live something with quantum entanglement, but we didn't really get into much quantum either. But quantum is going to be important. And see, part of it is that this stuff is still under research, so I don't really know exactly what the answers will be. But I think quantum mechanics will probably have a big role. And like this negative pressure thing intrigues me a lot. And that probably does have to do with quantum mechanics. I mean, what else could it be, the virtual particles? Like, I feel like it's probably something to do with that, is probably the nature of dark energy. Again, because we don't know, and it's, a topic of research. Did you think, Nicole? Think what? Milo! Hi, Jays. Thank you, Milo. Hi, mechanics. How are you doing? I actually need a mechanic. It's a pleasure being here. Thank you, Ben. Thank you, Nicole. Thank you, Scott. Milo, thank for the sun. Hi, US guy. Oh my goodness, guys. Thank you for the gifts, guys. Ooh, let me heart and like Milo Torres. Milo Torres. Wow. I need both quantum mechanics and a mechanic. A classical mechanic. I need both quantum mechanics and a classical mechanic. You're welcome, such a brilliant, beautiful mind. Thank you, Milo. You are so very welcome, Sunshine. Oh, thank you so much, Nicole. Hi, Ling Ling. What's my opinion on foot? If people practice it safely, sure. It's beyond the scope of my discussions. But I don't want to discourage anybody from doing something that they love and that's something that could support them. You know what I mean? Number 1 top fan right now is Scott. Number 2 is Nicole. Number 3 is Milo. And something that does not hurt others. That's the most important thing with anything that's questionable. You know what I mean? That's very important. Okay, number 1 is Scott. Number 2 is Nicole. Number 3 is Milo. Number 4 is Slime. Number 5 is Ben. Number 6 is Mr. Vision. And where are you? Actually, I now want to look at space-time. Space-time entanglement is now number 14, so you are kind of slipping here. Space-time, maybe you should do a gift and come back up a bit so I don't have to scroll so hard for in order to see you. I'll do a new goal just for you because I'm the normal vehicle type, but don't mind dipping my toe into the physics. You should, and you should subscribe. You should keep coming back. Classical mechanic. You're a classical mechanic, and that's totally fine. That's great. We need them. I made a new goal for you guys. Such as... Oh, you're... Thank you for subscribing. Scott, are you still here? I made a new goal for you guys. So you can come back up a bit and I don't have to scroll to the end of the earth in order to find you. Scott, you should go and see the beginning, like rewind the live at some point because I feel like you missed a lot and we did miss you. And we have been discussing a lot of really interesting topics. So I hope you can catch up. And keep coming to my lives with your money. You work so hard, you deserve to spend it on this live. Thank you for subscribing. Okay, let me get my water. Is Baji here? I don't know. Let me get my water. Also, I am planning to change that cat tower because it's gotten very worn out. Love your smiles. Thank you. Scott and everyone, you work so hard. You deserve. You deserve it. You deserve to spend it here while you relax. Just I know it's well loved. You're right. The mechanic, the classical mechanic has spoken up. I love it. It's so tight. I need help from the mechanic. Oh boy. Oh. I cannot open something, guys. Oh, here. The Stanley mug is the same size as me. Hi, Milo. The Stanley mug is the same size as me. And it got a bit stuck. Hey, hey. Ho, 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 ho. Mm-hmm. Namaste. Hello. What the heck, YouTube? Why you put me in 6th? Can I? Yes. Can I do this? No, it's fine. That's a cup. Yup. I'm gonna fill it up now, but I wasn't being able to rotate this, but now I am. Hi, Master. How are you doing?
I did go swimming today, guys. I did go swimming. I did go swimming. And now I'm going to be swimming in the cup. Do you guys, by the way, guys, I got the cheap Netflix so I could catch up on some of my shows. And guess what show I'm watching right now? Guess. You don't think that's enough water? Hi, Sonic. I'm sorry, guys. My internet reset itself. Say hello to Boston for me. Hope you're catching up with the Boston games. That's my cue. You're on time. See you later, chat. Connections looping. I know. I looked down at my internet and it was kind of like, what do you call, blinking. I think it reset itself. Oh, sorry about that, guys. Thank you so much for being here. I got my water. I wanted to say hi to everybody and bye to everybody, and thank you so much, everybody, for being here, for supporting, and thank you, Scott. I never went anywhere. It's just my internet reset itself. As a passenger princess, I just waited. So yeah, and I can't go anywhere because I'm a passenger. So yeah, I'm here. I am. I was just gonna do a little chat with you and say goodnight. Can we get one more subscriber? I need a good number of subscribers. Please. Please. Can we? Because you need a mechanic. I do a classical one. Although we discuss quantum mechanics, we do need a classical mechanic. Guys, if you see my shorts, videos, clips, lives, please like, share, comment, and show your love. I really need it. Please. It's early biomechanics for dummies. Ben, good luck and good morning and good night and sleep tight. Poor Nicole must have given up. But she really supported me. Good morning. Oh, look at that. Kaleidoscope glasses. Oh my gosh. Kaleidoscope glasses. Thank you, the dude. The dudeski. Can we get 50 likes? The dudeski has done some glasses of a specific nature that I'd never seen before.
Near to Shabbat. Good morning, Ben. Good afternoon, almost. Thank you for the glasses. Oh my gosh. Look at that. Hello. Hello. Thank you, Dudeski, for the cat ears. Hello. I love the cat ears and the glasses. I think I like the glasses more actually, but both are great. Wow. Thank you, Scott. Thank you, Nicole. Thank you, Ben. Let me read the top fans now. Number 1 is Scott Romer. Number 2 is Nicole. Number 3 is Dudeski for doing those gifts. Number 4 is Milo Torres, also did gifts. Number 5 is Slime. Number 6 is Ben. Number 7 is Mr. Vision. And so on and so forth. If you want to come up in this list, then you can help me with my goals. Nice cat ears. Thank you. Thank you, thank you. It's been so lovely to see everybody tonight. I have missed you. I need to go live more often. I think I will have a lot more regular physics classes, especially in the fall and winter. Spring and summer, it might be a little sparse, but I'm going to try my best to do as many lives as I can for you guys and do the topics that we love to discuss. Thank you. Can we get 50 likes? I'm seeing 47. Can we get 50? No snacks. Should I get a snack? Oh my god. I kinda want some Hot Pockets. Should I do it? Scott, don't you have work in the morning? Scott, you must work very hard and keep getting promotions and keep making more money and feel free to spend it all here on these lives. You deserve it. You deserve it. Now, Seth, how are you? She's back. I want some Hot Pockets too. I think I'm going to warm up some Hot Pockets and eat, you guys. Long time no see. Software engineers unite. Go ahead, guys. Double tap done. Good job. Yay. Any trips planned? I've been covering a lot of hotels and travel content here in the Boston area. I did Florida, I did Ohio. I want to do more. I really want to do South America. So that's kind of a plan, but I don't have it booked yet. Hi, Lions. I'm uniting with you. Hello, Lions. Thank you. You should subscribe. You should. You're coming back to New Jersey? Yay! Like and subscribe. Please. I never said that. Message and pinned it. But I'm doing so now. You should subscribe. And like. Really? All the family? Oh, good. Safe travels. Scott, are you traveling? I think you said you go up north, right? New Hampshire, Maine, or something? Oh, that's right. I remember I was going to change the thumbnail. I gotta do that. You were there during the storm? Oh my god. Yeah, we got a lot of snow. Probably you got more. Thank you, Speed. Hello, I love you. Your channel is awesome. Thank you. Oh my gosh. You're so kind. Your face makes me happy. Oh, thank you, AII. Calm. Okay. Arizona. I love Arizona. As in, I loved the Grand Canyon and the Antelope Canyon. I was there a few years ago. Did you ski? I don't know how to ski, so. Me ski? No. Okay. Same. I don't know how to ski. Thank you guys for the 51 likes. Greetings from Hamburg, Germany. You have beautiful hair. Thank you. Hello, Gary. Gary from Germany. Welcome. Please subscribe. Can you subscribe? We talk about physics, astrophysics, astronomy, cosmology, kitty cats. Oh my god, that's exactly what I say to my friends who talk about skiing. I tell them that I'll just drink hot chocolate inside. I found my hot cocoa twin here. Germany, hello. For now, keep my family here in New Jersey because my uncle. Yeah, your uncle is 92. Yeah. Keep them. Keep them in New Jersey. It's such a good location. You know, New York is right there. You've got everything in New Jersey. Just stay there. Stay. Hi, Free. Hello, Free to Play. Oh my gosh, thank you so much for helping with my goal. With my goal, yes. You live in Jersey? Look at Scott and Ben. Both New Jersey. NJ for the win. Not too far from Boston. We're all neighbors. We're all neighbors. Honestly, guys, I might just get the Hot Pockets. I'm a little hungry now. Before bed. I'll do a meetup at some point. I will most certainly do a meetup at some point. Brazil, welcome. Hi, Renal, Dory. Hi, Brazil. How are you doing? Your message looks different here versus here. That's kind of crazy. Okay, you know what? Please let me microwave the Hot Pockets and then I'll be back and change the thumbnail. Because, you know, they also have to cool down a bit.
has 1% charge. Okay. $2.50. Okay. Hot Pocket is cooking.
Dark energy talk about snacks got her hungry. Yes, I'm hungry. I'm hungry. Guess what show I'm watching at the moment? Guess. 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 147.15. I got one more subscriber, guys. Can we get many more? Scott, Ben, can you ask all your uncles, aunts, neighbors, relatives, sisters, brothers to subscribe, please? I really need it. I really do. Could you please do me a big favor? It's not Game of Thrones, because I don't like violence. Did I tell you guys that? Did I tell you guys Game of Thrones? Yeah, I have Netflix. The cheap one. The cheapest possible Netflix. Did I tell you guys? Could you please tell your uncles, aunts to all subscribe? Why did you unsubscribe? Hi! Hi, John. What about plasma? What kind of plasma? And can you please subscribe? Okay. Goodbye. Hi, Throb. Good night and sleep tight. Electricity. Well, thank you, Speed. Maybe next month be in Boston for my work. Wow. So your question, John, might have to pick it up next time because now I'm going to be busy eating, and I covered a lot of science tonight, and I'm a bit tired now. But please do come back with your question next time. Please do, and please subscribe so I can keep seeing you again and again. Again and again. You'll be in Boston? Well, you should see my Instagram and or TikTok. I post about Boston a lot in those platforms, and I give hotel recommendations, tourism, travel, all that stuff. Here's the Hot Pocket.
I'll let it cool down a bit.
You should subscribe so you can hopefully get notified when I go live. There is no way that you did a super chat and I ignored it. Don't lie. Any Hilton? Oh my gosh. Well, let me share with you a Hilton then. If you subscribe and do the bell notification thing, hopefully it notifies you when I'm live, okay? And then my shorts come out like every night or every day, actually. My shorts come out every day. Videos come out every day, but there's a gap right now. I need to post more. And my lives, hopefully you get notified when you subscribe. Okay? Love to see you. Thank you. And come with your questions about astronomy, astrophysics, cosmology. I ignored you? Aw. Do one now. I won't ignore you. There's no way I ignored you. Did you change your username? I don't change. I don't really ignore my super chats ever. The sarcasm. I feel like I'm not really in a position to manage your emotions, darling. You know what I mean? I hope you're happy with life. And it would be great, it'd be cool if you subscribe. But if not, I wish you well. I wish you the best. Okay? I do wish you the best. And also I'm going to pick up this Hot Pocket. I'm going to Boston, dear, next month to headquarters in Cambridge. Come to Cambridge. RTX Baby and Technologies. Wow. Maybe I'll organize a meetup when you're here. Scott, let me give you a Hilton. Congratulations, Ben. What? Eat all what? Ben, can you take care of this situation? Next year retired. Yeah. Well, congratulations, man. It is so hot. Oh, how dare you. I'm going to take care of you on myself. Goodbye. Hi, Jane. Ben, thank you so much for your services. Scott, you're also 21 years? Mm-hmm. Definitely long time. Um, my Raytheon guy. Samuel, are you gonna do a gift? Thank you, Sergio. Oh my god. Thank you. I love that gift. Thank you, Sergio, for your gift. Mm-hmm. Okay, I changed the thumbnail. I was hungry. Please don't fight Ocean. You're too beautiful? Really? I love the ocean. I do. That's why I moved to Boston. I love the ocean. Stay safe, everybody. Okay? Take care of yourself. You guys work hard. Good. Take care. And spend your money here. You deserve it. I do. I go to the beach, yeah. Hi, Flamon. Raytheon is one of the places I have not worked in, actually. Have you climbed ice wall? Wow, Speed is saying I've been at my job for 30 years. You guys are all veterans at your careers. I know, Ben. I was at MIT Lincoln Lab, so we worked with, um, all the organizations all the time. She was so defensive at MIT. Would I date Neil deGrasse? No. He's like a father to me. What the frick? Livermore and Los Alamos labs at test site. Wow. I still remember that story of you at MIT. Really? Did I tell you guys a story? Gosh. What did I say? Goodness gracious. Wow. It was nice there. I liked it until I did not. What are you laughing about, Sergey? Oh, the father thing. I do AI stuff and I do content. I used to do the other things. And whatnot, but not anymore. Yukon Mountain and forward areas. B, stay here for a while in New Jersey. We go way back to New Year's Eve cast. That's where I super chat for the first time. Oh, we do go way back. I know that. But I think your memory is good. Like, I didn't remember the specifics, but thank you, Scott, for your excellent memory. I've done a lot of these lives, but back then, yeah, I was doing lives a lot, which I'm sure it'll happen. Like, fall and winter, I do more lives. Spring and summer, maybe a little less. I'm so busy right now. I'm gonna try my best to do as many lives as I can, but I have so many contracts right now, and they are all constantly, things are due. So I became a consultant, and I don't like, I'm not an employee anymore, but I do contracts, and I kind of like it. I like remote work, and then I also have time and space to do content. So you had your plate top and being cold. You are right. Oh my god, I know exactly which outfit you're talking about. It's actually a short dress, but I wore it as a top because the dress is too short. Yeah. You're right. Oh my god, Scott, you got it. I had my plaid top and I was cold. The plaid short dress that I wore with pants, probably because it's so cold. And the dress is too short. It rides up. Correct. Hope reunites all the Boston and New York. It does. We are between Boston, New York, New Jersey. Who else? Arizona. Thank you guys. It's been so lovely to reunite with all of you tonight. Soon I'm going to do my kisses and then go to bed. I changed the thumbnail. All right, you guys, are you ready for the goodnight kisses? Baji did a live on March 26th. Then I did my gamma ray bursts. Sorry about my sniffles. I did my gamma ray burst live on April 9. And then now April 23, 24, I'm doing this one. I hope to be back very soon. Until then, please take care, stay safe. AI spooky experiments. Yes. Take a vitamin C zinc supplement before bed. Thank you, Milo. That's a great suggestion. That's a great suggestion. Wow. You're so nice, you guys. Milo, did you subscribe? I hope so. Okay, I have some shorts coming up. I'll do more videos and I'll do more lives. Baji is quantum entangled. Oh, I was going to give you a Hilton. Photograph memories. Yes. Scott has a good memory. Use my video to book if you can. I've been subscribed. I text a friend to sub. Oh, thank you. Thank you. Thank you for asking your friend to subscribe. You had a laundry to do and complained about leaving the building. Oh my gosh. You are so right. You're so right. It's my birthday today. Do you think you could wish me? Of course, Stella, darling. Happy birthday to Stella. Yes, I'm working remotely next year. Are you able to work remotely? No thanks for you, meaning? Is there a remote job for me there? Actually, I don't want a full-time standard job. I'm happy now. I'm happy the way I am. I can't do it. I'm tired. I like working for myself. Go to bed. Go to bed and me go to beach. Wish I could work remotely. I know, right? I was on site for years and years and years and years and years and years. And I don't miss being on site. And I really don't want to go back to on site. I really don't. Okay, wait. So Scott, do you have TikTok? Even if you don't, look at my video, because you can on a browser, and then try to use my video for your booking. Let me show you now. Hi Pankaj. Hi Shocker. Hi SH Jill. Please subscribe, guys. I need it. Hello, darlings. Please subscribe. Please. Don't play about me. Subscribe. Good night, Ben. Mwah. Mwah, 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 mwah. Be safe. My internet is being slow. Let me grab your... What's your username again? Scott Romer. At Scott Romer. I'm gonna share the video and tag you on my posts, okay? I just ate a hot pocket, now I gotta... Enjoy. Warm tea, you sound like... Thank you. I enjoy on-site because I meet new people every time I work. Yeah. Thank you for being subscribed. Okay, Scott. Thank you so much. Again, everybody. I will tag you in my... when I share the hotel, okay? For Boston downtown. So, thank you, Milo. All right, guys. Now for the goodnight kisses. Mwah, 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 mwah. Thank you, everybody. So nice of you to join. Really missed you. Mazel tov. Congratulations. Happy birthday. Everybody whose birthday it is. Missed you so much, and I hope to see you soon again. Please join us when we go live. See our shorts videos, and love your support. Thank you so much. Catch you later. Bye. Good night, guys. Love you. Bye. Good night.